Alright, welcome to Module 11. Now, in Module 11, we're going to deal with sets, bags, dictionaries, and there's different implementations that we can use, and the structures are different. So, I apologize ahead of time if the storm takes out my audio briefly, but we'll just hope for the best. All right. So we're going to use Python as we've been using, and we're going to create a set. Now, by now, if you're familiar with the structure or what a set is, and it's just a grouping of items or values, things, that don't have any specific order to them. One rule that we've got to play by, though, is that all the items there are unique. We don't have any duplicates. Okay. So the numbers 1 through 10, that's a set of numbers. No duplicates. If there were duplicates, then it's not a set. Okay. So now that we've got what a set is, let's look at some examples that they've got here. And whether we're dealing with a set of numbers, is this a subset of the other? What's in both? Let's move forward. So we've got some commonly used operations, and a lot of this is stuff that we've dealt with before. Len, iterate through it, string, add, remove, get. Now, we define S as an instance of the set class. So we create a set object, we'll call it S. From that point forward, that's our set object, and we refer to it as S, and it's an iterable object. So we're going to create a set that has all unique items that's in it. It could be strings, lists, dictionary, whatever it may be, and it's going to be assigned to this object we called S. The different functionalities or methods, they're things that we've used in the past. Here we've got a set A and a set B, and is 1 in A true? We're going to add 1 to B, add 1 to B again, add 5 to B. You can't have the value in there twice, so it ignores it the second time. So if it already exists, it's not going to do the work. We could write some code that throws a message back and says, hey, that's already there, we can't do this. But with this, it just ignores the fact that you wanted it to do something it's not allowed to do. Okay, we go remove an item, it pulls it out. Check to see if B is a subset of A. Comes back and it says yes, it is. For item in A, print the item. There we go. Put this at the end of the line to delineate or show that we are at the end of that statement. All right. Okay, so sets, they use sets a lot in math. We'll use sets a lot in data science. So one of the things that we'll also deal with in this module is going to be dictionaries as well, but we'll talk about bags. We talked about bags back in chapter 5, and it's just an unordered collection of elements. You just think about it like there's just things in a bag. But the big difference between sets and bags is that sets have unique items, whereas bags can have multiples of the same. Now, think about it like I can have a set of playing cards and I can have a bag of Legos. Now, if I look in the bag of Legos, I'm going to have multiples of some. If I look in the set of playing cards, I'm not going to see multiples. Well, unless we're talking about jokers, and we'll just ignore that aspect of it. I'll just talk about the 52 cards that would be in a deck or a set. Okay. So some of the operations will be the same, some of the functionality will be the same between the two. Now, when we talk about sets and dictionaries, right? Dictionaries, they're also unique value or unique keys. Now, a dictionary can have multiple values associated with it. A set, when we find the item, the value is there. But if we're looking at a dictionary, we find the item, which is the key, there could be multiple values associated with that key. And we think about it like a dictionary relative to words. Excuse me. In a dictionary, a word can have multiple values, or let's use the term meanings. You look up a word, and here's meaning 1, meaning 2, meaning 3, and they're all associated with that same key word, but they're different values associated with it depending on a context. So we look at a set, they're individual values. We look at a dictionary, they're keys with values, individual unique keys with values associated with them. Okay. So the keys are unique, the values in the set are unique. So they have that commonality about uniqueness. Dictionaries are not necessarily ordered. I can make them ordered, but they don't have to be. So we can go create a set. We'll add things to it, remove things. We'll use an abstract collection. We'll have a bag. And we'll go through whatever it is. Are we going to have a linked bag, abstract set, array bag? How are we going to have this set up? So we will instantiate different things depending on what we're going to deal with. So I could use an array set, a linked set, or an array sorted set. Classes that already exist, I'll just implement whichever one. And they will inherit from the parent class. So I have this array bag. Difference between an array bag and an array set: duplicates in a bag, no duplicates in a set. So if I take the bag and apply one more rule to it, that makes it a set. Take a linked bag, apply one more rule to it, must be unique, linked set. So we can reuse things that we've already got. We just apply another rule to that structure to make it what it is. So we go through these in the exercises, and it's not such a bad module when it comes to the exercises. We'll go through and we'll create this equality method if these two objects, self and other, are equivalent. We'll use the array set class, or we'll create an array set class based off of the array bag. So we'll import an array bag off the array bag set, use abstract set to create our abstract set, and then using those two, we'll create our array set. So it's a set founded on these rules. The difference here, we're saying it's a set. Here we're saying it's a bag. The two combined, well, that'll make it an array set. Okay, so sets are not so bad to deal with. Dictionaries are a little bit different because we can navigate by the key, or we can search by value if we need. We traditionally will navigate by key. Just like if you're going to look a word up in the dictionary. Word is the equivalent of a key in a dictionary. So we'll get the item and a key, so it returns the value associated with a key. So essentially that's like saying, get the meaning or the definition of the word. So the word is the key, the definition would be the value. Oh, it has multiple definitions. A key can have multiple values. If I want to set an item, we go to the key and associate a value with it. It's like adding a definition to a word. If the word doesn't exist, okay, we need to create a new key or add a key. So functionalities are similar to things that we've used already. The logic is so similar to a traditional dictionary, Webster's dictionary. So set it up as an array or a list. In this, we're doing an array-based structure. So we've got our abstract collection, abstract disk, or dicts, and it could be a linked list dict or an array dict. Either one, whichever one we choose to use. So an entry object, an entry is a combination of the key and the value. So I can't have a key without a value. I can't have a value without a key. So if I have the value and the key, that together makes an entry in the dictionary. So if we think about that analogy of Webster's dictionary, I can't just have a word in there without a definition. I can't have a definition without a word. But the two of them together are an entry in the dictionary. Okay? So we'll create a class of entries, and they have a key and a value associated with them. Now, in the dictionary, we would say dict key or dict value. And here we see that happening. So when we go to create it, we go to that location, find that key that matches the dict.key, and then I go find the value associated with that key. Okay. So we'll create our abstract dictionary class based off of a collection, and we'll have the object we're creating, the keys that we're bringing in, and the values that we're bringing in. And we'll go create this dictionary object. I can join entries together to create my dictionary. If I want to add an item or add dictionaries together, have functions that will allow us to do that. And then we'll have modifiers or mutators down at the bottom. And we'll go through this in the exercises. Okay, so I've got accessors. I can go iterate through it. It's fairly straightforward to use a while loop. As long as I haven't reached the end of it, let's just run on through it. Get the items that are in there. Go modify, set. It's not a get, it's a pop. It seems my system has glitched up with a little power surge. There we go, just recovered from a little power surge. If we look at the complexity analysis of these structures, sets, and dictionaries, right, it's not as simple as looking at a tree or navigating a tree. Now, we'll use hashing strategies to be able to deal with this addressing when we're talking about these dictionaries, how things are addressed. And I can use a hash table to know how this is all tied together. Because if we think about it structurally, I've got, in essence, it's kind of a two-dimensional array, but it's not. So it's almost like I have one dimension, the vertical dimension. Yep, there's my keys. But then as we go horizontally, it's not all the same. One key may have a single value. Another key may have multiple values. So this gets kind of complex, so we end up creating this hashing function to be able to address what's taking place here. Okay. And it gets complex. It really does. So in the previous one, they were talking about hashing, and we end up with collisions along the way. I don't dig super deep into this conceptually, and we don't get beat up on it so much when it comes to the exercises. I'm going to jump through here. We do hash a little bit, but it's pretty straightforward. Now, this linear probing, essentially we're looking to see, is there something there? Has it been deleted out? And conceptually, that's what's taking place. It's just looking to see, is there something in that place? will have code associated with quadratic probing. You see it here. And we'll use this multiple times in the exercises themselves. So you'll see this again and again. So we'll deal with chaining, and essentially, here's that structure I was talking about. So if these were the keys, we would point over to linked lists for each key. So I've got 5 different buckets. This bucket's got nothing in it, but I've reserved it in case I need it. It's not an ordered structure. So it doesn't matter what order we've got it in. We go look by name or by key and then look to find the value. Now, depending on how we go about things, we're looking here at the complexity of it. I'm not digging deep into the big O notation or time complexity of this structure. Okay. Go through here, and it should be pretty straightforward depending on how we're looking at what's taking place. I could be constant, or I could be linear. Now, we will go through this over and over again in the exercises. One of the things that you will see time and time again is we'll need to check to make sure if something is actually there before we go do any action associated with whatever they want to have done. So we'll go ahead and raise an exception if the value is not there or if it is already there. So if I go looking for something and it's not there, throw an exception. If they want me to add something, and we're talking about in a dictionary unique values, we're talking about a set unique values, I can't go add something if it already exists. So we will throw exceptions on those items when that happens. We'll go through this in the exercises. Actually go through hashing implementation in there as well. The dictionary can be sorted, doesn't have to be. A set can be sorted, it doesn't have to be. If it is sorted, it makes it more efficient when we're talking about time complexity. The more organized the data, the more structured it is, the more efficient we're going to be in accessing and manipulating it. Okay? So we will deal with a linked binary search tree when we go create this collection, and we'll have this exact code in at least one exercise. So from there, I'll see you in the exercises. Hopefully you waited till you saw this until you jumped into Module 11 exercises. I'll see you in the exercises, and then I'll see you in that last Module 12.